Welcome everyone to Flyte's community meeting, monthly community meeting now. Today is February 6th. I'm David Espejo. I will be your host today. Okay, a couple of reminders. This meeting is being recorded and the recording will be available in the Flyte YouTube channel. And also this meeting falls under Linux Foundation's Code of Conduct, which means be nice to each other. Cool. So today we have a interesting agenda, in my opinion. Let me share again here the link in the chat. Remember that the agenda is an open document, which means if you scroll down a bit to the open mic question section, you can add, you can hit the edit button at the top left. I will share my screen a bit. And you can add a question or a discussion topic to the open mic section. So the agenda is also yours. Cool. So yeah, as you see, we are using today a different Zoom link. More on that a little bit later in this meeting. And so let's get started. I'd like to welcome everyone who's joining for the first time. I see many folks joining for the first time. So if you want to briefly unmute yourself, introduce yourself to the audience, that's cool. That would be great. So for any one of you joining for the first time, welcome. Would you mind introducing yourself quickly?
Sure, I can start. I'm Andy Czerwonka. Yeah, it's my first meeting. I'm a platform engineer, principal engineer at Citrine Informatics, which is an AI company who works in the materials informatics and chemical space. So we provide a platform for materials engineers to create new materials. And we're looking at we're piloting some kind of async compute offloading technologies, and Flyte is kind of a very interesting one for me. And I'll throw myself in the open mic later potentially, and maybe if there's time, a couple of questions. But I appreciate the timing here because I was just starting this effort a couple of days ago. So thanks very much. And
awesome. Welcome, Andy. Yeah, I see that you already asked a couple of questions. Hopefully we'll be able to help you on time. So yeah, welcome. All right, anyone else joining for the first time and would like to briefly introduce themselves?
Yeah, sure. I can go next. I'm currently blocked by cabinets, so I'll probably turn my video off because you don't want to see half my face. But I am MLOps, kind of a data engineer at Kernel. We do neuroscience, and I'm looking into different data kind of pipeline orchestration solutions at the moment because my life has gotten miserable with managing things at scale. And so it looks interesting. So I watched a couple of videos and just looking to see what other people are building.
That's awesome. Yeah, thank you for joining. And just curious, how did you find about this meeting?
I think I went to the Flyte website, and then I was, I have I like these kind of meetups because you get to see what people actually build, and I find that very useful. So I was looking for something along those lines, or recorded webinars that maybe some people had already done. So I think that's how I found it.
Awesome. Yeah, welcome. There's a question. Is your company Kernel, that like kernel.com? Or
yeah, that's the one. Neuroscience. We have a fancy helmet that scans your brain, and we want to do things with that, and that requires processing at scale, and so that's why I'm here.
awesome. It's great to have you here. A very interesting name. Cool. Right. Anyone joining for the first time that would like to introduce themselves quickly? Nope. All right. No problem. It's not an obligation. in any case, we're really happy to see you here. You can also add your name to the actual agenda doc, and we'll point it here just one more time. And cool. So let me share my screen right away. Why I don't see share screen here? There you go. This one. Cool. Alrighty. Great. So this is what I mean. You probably see this. If you go to the top left section, you can hit this view or even this view. And if you scroll down a bit, you can add a question or discussion topic right here. Okay. Cool. So let's move to the next section. News from the ecosystem. It's a let's say a raw summary of some of the stuff that we consider are useful for some of you out there and that have been happening in the past month. So first one, the Katie Nuggets survey, I think is the 10th year of this survey, and the results are not great. Almost, let me see, yeah, only 22% of the data scientists that were part of the survey can confirm that their revolutionary ML models actually are deployed somewhere. So most of the revolutionary, it means here models that enable a new process or capability. And basically, these kind of models are rarely deployed ever. Almost all the times never get to production. It's slightly better for existing models, existing initiatives, but for new kind of stuff, it's a bit harder. There are different reasons. I think the document is very interesting. It's not only technical reasons, as you probably can figure out. There are communication issues, not being able to properly and on time communicate the value of a specific ML model initiative beyond just research. Actually creating value and communicating the value to stakeholders is a key component into these models actually not being deployed. And yeah, they try to find out if probably this was an isolated pattern, but it seems like deployment is bad everywhere. So yeah, very interesting. Next one, Hugging Face open sourced a data processing text data processing library written in Python called DataTrop. So looks interesting. PyTorch 2.2 is out. I think it's this one. Some beta features. One of them is the ahead of time inductor that basically will take PyTorch modules and compile into a shareable object that you can run without a Python runtime. Interesting. Cool. The Ellen Institute for AI, they released an 7 billion parameter model. It apparently outperforms Llama 2, but more importantly, it's open as in model weights, the code, the pertaining data, everything is available under an Apache license. So seems to be more in the vein of truly open. Speaking about C++, Microsoft seems to continue the trend of moving from C#. In this case, apparently from a job post, we can infer that Microsoft 365, Microsoft is building a team to adopt Rust as a programming language for modernizing some of their core products, including Office 365. And yeah, seems to be a bold move to prioritize memory safety. And finally, a really interesting paper, Slice GPT. In summary, it replaces the weight matrix with a smaller matrix, and it reduces it removes up to 25% of the parameters while maintaining almost 99% of the performance for some of these models. So really interesting. It's helpful for resource optimization. And finally, a great resource for folks like myself who don't hold a PhD on NLP or machine learning or something like that. How to actually an LLM works from scratch. How to build an LLM from scratch. And the book is a work in progress, but the repo is already there with some of the examples. And yeah, really interesting resource. All right, any comment around this? Sorry, around this news, etc. Comments? Cool. So next up, community updates. The February newsletter is out. We have this monthly digest summary of everything that's been happening in the project. The newsletter issues out, so you can hit this link and subscribe. It will take you to the Linux Foundation mailing list. And you can just subscribe and you will get the monthly newsletter. All right, this one is interesting. For some time, we've been trying to have different resources to better support the community. In this case, it's a bot and basically a GPT, an LLM that is being trained on the Flyte documentation, the Slack archive, the blog, and readmes, issues, discussions. I mean, everything is except code. It's not supported right now. And the bot is already available in the Ask AI channel. Let me see if you can see this. This is how it looks. So I will be inviting or adding the bot to the Ask the Community channel. So if you mention Glime, and if you don't do anything else, it won't do anything. If you don't mention the bot, nothing will happen. It's not that it will shortcut every question in the channel. It's only if you actually mention the bot and if you ask it a question that it will be triggered. So I don't know. Yeah, probably this is not a great question, but just to show you, it will add this reaction to kind of show you that it's busy generating a response. And you can help us make it better by giving it feedback. The feedback is basically a thumbs up, thumbs down reaction, as you can see here. For example, I just copy pasted this question from the Ask the Community channel, and it created this answer that I can say it's fairly correct. It could be that it's a model that it could still hallucinate. So have that in mind. Take the recommendations or the answer with caution, but you can help us give it feedback with thumbs up and thumbs down reactions. So yeah. So if you happen to need support from anyone, and I don't know, it's a weekend or really late in the night, and you want to try to see what the bot can do for you, just mention Glime and ask a question. Here it is. It will give you sources, and as I said, it also it's been trained also with the Slack archive. So probably sometimes it will refer you to past discussions, which is interesting. Cool. All right. Next one. Where are you? Many tabs. Okay. Migration to LF-Zoom. Yeah, this one is interesting. Let's say, so as probably you know, Flyte is a Linux Foundation, Linux AI and Data Foundation project. So in summary, there's an initiative from them / mandate to migrate all the Linux Foundation projects under their Zoom account. That is helpful to try to centralize everything. It's helpful for projects and kind of giving all of them the same resources. So what does it mean for you? Probably for the next community meeting, which is scheduled for March 5th, you will see a different Zoom link and a different experience. Let me show you real quick. So this is a test account. So it will prompt you this. So if you see sign in, this is not a Zoom account. This is a Linux Foundation account, and you don't need one, right? If you don't have one and you don't want to create one, you don't need one. You can join as a guest, right? Creating a Linux Foundation account is useful if you want to see your contributions throughout LF projects in a single place and meeting recordings from different projects in a single place. But you can join as a guest, right? You'll need to provide your name and email address if you want, David. And well, I cannot hit join, but this is the experience. This is what you will see. So I used to think it was an option. It's not. It's a mandate. So this is something we need to do. So starting from March 5th, community meeting and also the contributors meetup has to be migrated under this structure or this platform. We will be using the LFX Zoom account. Okay. Again, we will be communicating, communicating the new Zoom link. We will update the calendar. So if you subscribe to the calendar, you will get the update really easy. And yeah, don't miss the, yeah.
Maybe, maybe to make some advertisement for that, because as also the Open Security Foundation uses this, and also Onyx or Trusted AI Tech meeting. And if you have an account, you can, if it's configured in that way, you can rewatch your old meetings where you participated. You get some calendar overview with all of the meetings. I would say we at Onyx or the Trusted AI community, we had, I would say, a lot of trouble by migrating, but if you have an account and yeah, look around that systems, there are more pros and cons, I would say. So it's a really helpful systems. So, but I would say to get really the benefits, you have to have an account, and then you can make your own calendar and see what's happening there and rewatch the old videos and talks.
Awesome.
So I would suggest to create an account and then look around for the different meetings, and then you would have one central place for the Linux Foundation meetings.
That's right. Thank you, Andreas. And yeah, if you don't know, Andreas, you're part of the Onyx project among other initiatives under the AI and Data Foundation, right?
Yes,
and,
yeah.
And we've been longing to have you here sharing with the community about the Onyx project. So an open invite for you, Andreas. It's great to see you today. Cool. All right. And finally, don't miss next meeting. For the next meeting, March 5th, we will have one of the maintainers from the Open Lineage project sharing about, well, all things Open Lineage. So bring your questions. I think it will be a very interesting session. Okay, finally, without further ado, let's move to the guest presentations. To me, it's a pleasure to host today Marti Jorda Roca from Wallapop to cover their Flyte journey. So welcome, Marti.
Hi, welcome everyone. Do we start the slides, or just I present myself?
Yeah, probably you can start by introducing yourself, sharing with us something you enjoy doing outside work. That will be
okay. So, okay, thank you, David. So I'm Marti. I'm a machine learning engineer at Wallapop since 2022, and my job, as you may know, for machine learning engineering is to facilitate the life of the data scientist, building an ML platform for the company. And today I will explain that the journey of Flyte at Wallapop. So nice to meet you. Okay, I present the slides. So, yeah. Okay, so okay. Okay, you can see my slides.
Yes, sir.
Perfect. So as I said, today we are going to present the Flyte journey at Wallapop, or experience. For me, it's the first time that I participate so close with an open source project. So it has been very, very exciting. And I think also for all my colleagues at Wallapop that has been working in this project too. It's a very nice project and exciting experience for us. So for today's agenda, first, what is Wallapop, what we do in the company. Then I will talk about the past and present of machine learning at Wallapop, the story of machine learning, the projects, the architecture of the ML platform at Wallapop, and finally, how we have implemented Flyte at Wallapop, or use cases, and the pains that we have, the project structures, etc. Okay. So let's start. What is Wallapop? If you are from Spain, for sure you know what is Wallapop. Wallapop is the first second-hand marketplace in Spain. It was founded in 2013 in Barcelona with a very disruptive proposal for the time, being mobile first, geolocalization, and a chat for the seller and buyer. Also, it's a very, very strong brand in Spain, and since its foundation, it have exponential growth. Wallapop in numbers, for a little bit of context, we are currently in 3 countries, Spain, Italy, and Portugal. We have 17 million monthly active users, and these users upload daily new items, 300,000 daily new items. As we are a second-hand marketplace, we don't have SKUs. Every item is unique, so this generates a lot of data that we can profit from with analytics and with machine learning for sure. The history of machine learning at Wallapop. Okay, I think it's very similar to most of the companies, how we manage, we have managed machine learning at Wallapop. All started in 2016, where the data scientists developed the models locally in notebooks, in their own laptops, and most of the deployments in production, the few ones, were also manual. The last years of this period, before arriving to 2022, there were a few models that were deployed using Luigi and Jenkins. That was our data pipelines architecture at that time. And also we were starting using SageMaker Studio notebooks to develop those models that needs a really big, heavy computational resources. But Wallapop found that we need much more. We had a lot of use cases, and the platform, how we developed models was not enough. We need to build a machine learning platform. For this reason, in 2022, together with Ricardo, the other ML engineer in the team, we joined Wallapop to build a machine learning platform. So the first that we did was focusing on the continuous integration, continuous development, and continuous training using the SageMaker stack. In other words, we used SageMaker pipelines as the main tool for machine learning pipelines, and also increase the usage of SageMaker Studio notebooks, SageMaker endpoints, and SageMaker Managed Transform jobs. We built all of that with SageMaker because we wanted to build a platform as fast as possible and deliver a solution for the data scientists. Because with SageMaker, we didn't have a need to manage a big infrastructure like Kubernetes or other systems like that. All was focused on just the SDK of SageMaker and built a good project structure. But we developed a few models in production with this architecture, but we found that there are some issues with SageMaker pipelines. what is used. So first, what we wanted was faster model iteration. With this stack of SageMaker, we could not run the pipelines locally. We had to upload the pipeline every time to the Amazon cloud, run it, waiting. This was a lot of wasted time. Also, it was hard to debug. All the logs was only in CloudWatch, and for data scientists, it can be a challenge to read the logs on CloudWatch, and also a big learning curve. The SDK can be really verbose, and the documentation somehow complicated, let's say, and it has some strange, unique features that are very different to the people that only knows Python, basically. Also, we have to manage the environment installation. We need to define which pipelines are in production or in development by tagging, basically. So it was hard to track the runs and the data that these pipelines used, and the pipelines were slower. We had between 5 to 10 minutes of task initialization. So with all of this in mind, we thought that we need to change our machine learning pipeline to Link. In a few months, we researched the market looking for solution. We built some POCs, and then we decided that Flyte was our tool. So why Flyte? So with Flyte, we are much more faster iterating models, as the tasks and the workflows are pure Python, just a Python function, so you can run it locally. You don't need to upload it to your cloud provider. You can debug it as any Python code also. And for most of the data scientists that they only know Python, and the workflows, as I said, and the workflows and the tasks are only Python function, it was pretty easy to learn. Also, Flyte has projects and environments by default, so it's really easy to manage it. The data of the executions is saved automatically in S3 or other blob storage. And with Kubernetes, the slow pipeline execution was just a thing of the past. With all of this in mind, we the last year, in 4-5 months, we implemented Flyte in production as our main machine learning pipeline tool, together with other systems for the machine learning platform, like model data lineage with Data Hub, and for data quality, DBT and Monte Carlo. Okay, with all this context, let's talk a little bit in more detail about the technical aspects of how we have implemented Flyte at Wallapop. We are heavy users of Amazon Web Services. So we have deployed Flyte in EKS cluster. EKS is the Kubernetes service of Amazon. And the architecture, I would say it's the same that you explain in the documentation. The key difference, I think the most interesting ones are, in one hand, the notifications Lambda. We have built a Lambda that enrich the workflow notifications, adding the owner and other metadata, and also formats this message and sends the workflow notifications. The workflow notifications are those that explain if some pipelines or workflow has failed or is a success, and then we send this notification to us, the corresponding Slack channel. Each team has its own Slack channel to be out as autonomous as possible. And also, I think another interesting difference is the use of a Carpenter for cluster autoscaling. Carpenter, if you don't know, it's an Amazon tool that allows us to automatically add nodes to our AKS cluster in a very easy and naive way, and it works really well. We think with Flyte, because when you run a workflow task request some example, some 2 CPUs and 6 gigabytes of memory. If there is any node, if there isn't any node that has this resource request, Carpenter creates a new node instance with the best price performance option, so we don't have to worry about if it's a T3 EC2, EC2, or M5 EC2. Carpenter does this for us, and as I said, this creates a very naive for us cluster auto-scaling for Flyte. So it's a really good tool that I think you have to check it. This was from the point of view for the DevOps machine learning engineering. For the data scientist, our main objective for the data scientists is that they become as much autonomous as possible. For the reason, we have built a repository, the ML Platform project template. It's a GitHub repository, cookie cutter GitHub repository. Cookie cutter is a Python library that allows us to create new projects based on a template in a very easy way. On this project, we have a wood project, a structure, software architecture, also all the infrastructure details that the data scientist doesn't need to worry about, like the Amazon roles, the Kubernetes, the Kubernetes secrets, and all these kind of stuff that the data scientist doesn't need to work with. So data scientist just creates a new project from this template and has to worry about implementing the Flyte workflow. Everything else, the CI/CD, CT, doesn't need to worry, the Docker files, etc. Also, we have implemented another repository, which is the ML Platform for California. This repository follows the project template repository, but it's a real implementation of a machine learning a project. So the data scientists say, how I can query Redshift to gather some data in a step. So they go to the ML Platform for California and say, this is how we would do it. How we deploy a model to a SageMaker endpoint. So they go to ML Platform POC California and check it, how the project should look like. Okay. So with all this in mind, I will show you a little bit about this project structure, because we think that it's really nice. Okay, it's a little bit small, but hopefully you will see it. Okay, it's okay. Okay. So as I said, yes, excuse me.
I think looks fine. Probably.
I don't know if I think that with PyCharm I can
yeah.
zoom in the folder structure.
You can see it just fine.
We can see it.
Yep.
Yeah. Okay. Fine. Perfect. So for project structure, okay, all of our machine learning projects with Flyte follows this structure. There is a software architecture structure that we thought it's simple enough for data science to understand and follow the best practices in software engineering. So we have 4 main folders. One is the config. Here we have our project configuration file that explains the tags of the project, the variables or hyperparameters of our model, where is the data, the name of the project, etc. Then we have this parser that basically reads the YAML file and adds extra data and parses some environment variables like which env we are, etc. Then we have interfaces. Here, interface, it's basically this Flyte interface is basically a wrapper around the Flyte remote object. Okay, but we have extracted some things to be more easier for the data scientists to register and upload workflows to Flyte. It automatically chooses the image of the project, adds the correct tagging, etc. Then we have the pipelines folder. Here we define the workflows, the pipelines of our project. Here you can see here an example of the POC California that prepares the data set that is in S3, trains the model, validates the model, that the metrics of the model are correct, and if the metrics of the model are correct, the model is deployed to SageMaker. Okay. I think the most interesting part here is that we have coupled the orchestration logic from the logic of the task, and you can see it here. Flyte doesn't support custom Python models. Okay, the basic Flyte, you have to define all your task code here if you want to upload it to your remote cluster. But we managed to solve this installing the project itself in a requirements file in the development mode. So with PyFlyte run locally, this works. Okay, and also in the Docker file of the project, we install the project itself. So in remote, it also works. Okay, so with this, we have the coupled logic of the orchestration from the task itself that we are going to run and improve our code quality, clearness, etc. So final folder is the steps. Here we have the logic of the tasks, the steps, and if we go here to the preprocess main, it's just Python. So the data scientists can run this file locally or anywhere else and work perfectly. Okay. Everything of this comes together in our main file, as you can see. This main defines the workflow and registers it to the remote cluster, and if we want, we run it. Okay, this is for example is the last step of the continuous deployment when we deploy the pipeline to the Kubernetes cluster. Okay, so with this structure, data scientists with cookie cutter create a new project and just need to focus about implementing the pipelines and the steps of the project. Everything else, the CI/CD, the roles, the CloudFormation templates, and all this kind of stuff, they doesn't need to touch it. Okay, so we have implemented some projects on Flyte, and we have found some pains. We are really happy, but there are some things that we think should be improved. The first one, it's very personal for me, is that there are no manual guides on how to deploy Flyte core chart. There is this nice guide of David, Flyte the hard way, that deploys the Flyte binary chart, but there is no guide on how to implement the Flyte core core one. I think that in the past you had this in the documentation, but for some reason you you delete it. And for me, one of the green flags for Flyte was that it was this guide of how manually implement Flyte Core or Flyte Binary manually. Other open source projects hide it, that, and it's really good to have this, to create a POC fast and check that everything makes sense. Then sometimes it's hard to understand the error message in the task. You have to go to the pod logs or CloudWatch. In our case, every log of our workflow we send it to CloudWatch because the UI sometimes cuts the error message in a place that you don't understand what is happening. Okay, this one, choosing the right resource for a task is a trial and error. We have found in some of the projects that we have taken to production that choosing the optimized and the memory for a task that does very heavy, for example, pandas processing or query is just try it, increase the memory, try it another time, try it, and this can be a waste of time. I don't know if there is any guide on how to do it more faster, but it has been one of the problems in taking to production workflows in Flyte. Okay, the other one is hard to integrate custom Python models. As I said, we had to do this trick of installing the project itself in our projects. Rerun a workflow task. When a task fails in a workflow and you want to rerun it, you need to put manually the old inputs. I don't know why automatically this happens. It's just a small thing, but it's nice. Then we think that plugin maintenance is not clear, at least. We don't know which plugins work for the current Flyte version, if they are maintained or not. The plugins are just this, that we don't know too much about them. And also, we have found that there are old libraries or old machine learning core libraries like pandas and NumPy, I think, that are fixed in a version in FlyteKit. And if, for example, we want to move from pandas 2.0, that it's faster than the previous version, but FlyteKit doesn't allow this. At least the version that we are using the version 1.9 of FlyteKit. 1.9. But as I said, these are some pains that we have found. In general, we are very happy about Flyte. To give you a little bit more context, we have been able to deploy a completely new production model in 2 months with data scientist that it was his first time with a model of this kind, and also maybe with Python. So with just 2 months, we were able to deploy a complex machine learning project with a data scientist with little experience. And we have worked in some use cases for ML models, like improving our catalog quality. Every item, as I said, is unique. So we improve the catalog quality of them is very important for us. Improve also the load experience for the user to be as less friction as possible, and a short model. And we expect and we think that much more will become in 2024. Thank you for inviting me to this meeting. It's a really nice experience for me. Really, thank you. And if you have any question, this is the moment.
Marty, this is fantastic. Thanks so much for presenting and sharing. Really great. I'm John. I'm on the product side at Union. You mentioned in their early part of your presentation that you had set up a lineage tracking service using, I think, Data Hub. Could you talk a bit about how you did that? And like, I guess, what sorts of information are you persisting, and sort of any kind of high level overview of that would be awesome.
Yes, so Data Hub is also a really new project for Wallapop. It was taken into production just the last year. This was done by the data engineering team, and for the machine learning, what we have really is the machine learning data set that our model is going to be trained on is created with dbt. Okay, dbt automatically, how we have implemented it, Wallapop tracks every table created in Data Hub. Okay, and then we just need to link our model with this data hub, dbt table with a YAML file, a YAML configuration file in our project repository. So in a YAML file, you just say our model SageMaker X is linked to this dbt table, and that's it.
Awesome. Thanks.
Oh, Sami, you go next.
Awesome, thank you. I really appreciated the slide that, well, not just the slide, but the walkthrough of how you tried to encapsulate the workflow, the orchestration logic from the, the stuff the data scientist has to think about. That's something that I am really weighing heavily in considering different options. And so my question for you is, just how much Flyte do your data scientists have to know to be effective? Obviously, you've done some work in the template repos to abstract things, but still, how much of a Flyte logic do they need to know? Like, do they need to know about workflows and tasks, or do they just write Python script that does thing, and then you wrap it up in a workflow?
No, they write this. So the data scientists would write all of this. Okay, and the steps by themselves. This is for the last question. For the first one, so data scientists need to know a little bit of Flyte nomenclature. So what is a task? What is a workflow? What is a launch plan? What is a project? And the thing we found was harder for them was to understand that the code that you define here in the workflow function is not pure Python. It's a subset of Python. Okay, you can put an if here or a for. You need to write this kind of objects. This was a little bit harder for them. I think that yes. The other thing is just you understand it faster. What is a launch plan? What is a task? And what is a workflow?
Excellent, thank you.
Awesome. Ketan, please.
Hey, Marty, thank you for that presentation. That was really helpful. My name's Ketan. You'll probably see me in my community every now and then. My question was, it's more of a comment and question together. One is about the tuning the memory and CPU or the resource requirements for a task. It's a very hard problem, but we would love some insights. So again, not an advertise, but if you're using Union, which provides managed Flyte, it does provide a real-time live monitor of usage of CPU, GPU, memory, etc. as the task's running. Would that have helped in some way, or do you think if there's something else that you expect?
I don't think so, because we have this already with Prometheus metrics in Grafana dashboard, and we can see that. Probably for us, we could build some Grafana dashboard much simpler for the data scientist, because you have to understand a little bit of Kubernetes to see what is happening. So for me, the ideal, but it's just very just an idea. It would be something like serverless, or just in the logs show you how much memory the pod is expecting. But I don't know if this is something more about Kubernetes than Flyte.
Yeah, I think it's tuning is a hard problem, right? Like specifically, there is some overhead for Flyte kit, which we don't really capture. And if you are loading data frames and so on, they get loaded before. So there is some of these aspects. So good for me to understand. And the second one was about plugins. I think please help us identify the plugins which are not well maintained. It's a very hard problem to maintain plugins. One of the problems is that you have to write a plugin for Databricks, you have to pay for Databricks. This is how sad it is. But with agents, what we are trying to do is essentially make it so that you can run everything locally. And if that is the case, you should be able to test the end-to-end, including the plugin, the integration aspect locally. And I would invite the community members who have Databricks as a requirement to essentially run that simple integration test in Python alone and identify failures and report them back into the core. That way we can upstream these changes. But we would love help. And I think at Union, we are trying to work on a potential framework that allows you to run rapid number of tests very quickly, like at scale. So, and that might become like the de facto way we start testing Flyte. So, thank you. But please talk about which ones did not work. If it was SageMaker, I understand SageMaker's just broken. But that, and there is a new one coming, by the way, with agents.
We understand that it's hard to maintain plugins, but we expect at least I would think, and this is personal opinion, to be some explanation, to more detail in the documentation of the plugin about its status, it's safe to use it or not. But as you said, it's complicated to use this plugin, and your solutions may help a lot about this.
Thank you. Yeah. Please keep us posted about the problem. Thank you.
Okay.
Marty, just one last one. In your architecture diagram, you talked about sending metrics to Prometheus, and then having a Grafana stack to visualize them. What sorts of metrics do you care about? Is it cost, resource consumption, or is it more like SLAs on workflow completions and stuff like that?
So both. For instance, the cluster, if Flyte is running correctly, the metrics, how much resources has the cluster, etc. And the other metrics that we track is how many pipelines Flyte pipelines have been executed, how of them are in production, how many of them are in development, how fast we iterate these pipelines, new versions of pipelines arrives, how many of them fail. So to track this, for us, these team KPIs to see that the platform is working correctly as we expect.
Yeah, that's awesome. Super cool. It'd be great to see any if you end up having some good data about adoption of Flyte within the team, and if you see workflow velocity, kind of iteration velocity increasing, it'd be really cool to publish a blog on that for the community. With
yeah,
not if it's going down though, only if it's going up.
Yeah, for sure. No, we are happy with only this. To be honest, these 2 months was the first month that we started building production pipelines for Flyte, and we have now a fully complete production. We are expecting this month to have another one, and maybe these next 2 months another one. So in this Q3, 3 models in Flyte in production. We expect that. So really cool.
Awesome. Thank you, Marty, again, for sharing your journey here. Definitely open to learn more from you. Cool. So we are 2 minutes before going over time. And so we'll go a little bit over time with Byron and Troy's presentation. If you need to leave, well, sorry to see you go, but the recording will be available. And I want to be mindful of Andy joining and posting his questions. So real quick, I'll read it right away. The SCALA JVM ecosystem. So is it active? Are there companies running the Flyte Kit Java in production? Or I don't know if Andy, you wanted to.
Yeah, I mean, sure, I could just talk really quickly about those. And I also have an office hours meeting tomorrow, so I don't want to take everybody's time. But basically, we're coming from you know, we're on the JVM, and our services are written in Scala, like 95% Scala. So we're looking for a way to integrate to a Flyte kind of a world, right? We also have some Python, a couple of Python things going, and we'll be kind of not moving necessarily towards her, but a lot of our investments will be in the Python side. So it's not like we'll never use that, but right now, for us to be able to leverage it, we need a way to bind to the Flyte, you know, even though it says kind of, I get the sense, obviously, you know, even in the community and stuff, that it's really a Python binding, right? At the end of the day, and the Java binding is you know, kind of an afterthought. Well, again, which is fine if that's where the community lives, right? But I'm trying to get a sense of risk associated with adopting Flyte. So that's really where that question stems from: is how would we do that, and you know, what's the best approach?
Hey, Andy, my name is Ketan. I'm one of the leads at the Flyte side, and I also work at Union. So the Java Scala binding was actually created by Spotify a couple of years ago, and they use it in production at scale. They also use Python, of course. So
Sure.
The majority of the team, majority of the community uses Python. I think there are a couple users of Java Scala. There are not too many. That is one of the reasons why I also started a company called Union. The folks at Union really do not specifically help with Java Scala issues and bugs and development as much at the moment. Our goal is to get to it and do it like as we grow more. But at the moment, it is primarily driven by Spotify, and it's a big team at Spotify that actually builds and maintains it. I think the biggest problem that you'll find is authentication support in Flyte Kit Java Scala. Even though it's just OAuth2, it is not implemented because Spotify does not use the OAuth2 support in Flyte. They bypass it through a proxy. So I think you're going to find a problem with that. If the community, I think the community might have people who are good at Java Scala and might be able to fix this pretty easily. The experience, most of the structure, everything is kind of similar to Python, because when we designed Python, like that's almost at the same time Spotify started working on the Java design or adapting from the Python version. So it should be identical, but there is, and it is used in production. So it's not, you won't find like random issues, but I don't think the coverage is 100%, one. And then the second is you will find things like whatever Spotify doesn't use, you won't find those used.
Right, they won't be covered. There was somebody in the Slack channel here this morning that mentioned that they didn't even use that binding, and the only dependency they brought in was the gRPC bindings, right? And they generated their own stubs, and that's how they're interfacing with it. That seems like a reasonable kind of backdoor to me, right? Like if there was something that was missing, maybe if we can get around the authentication side of things, that might be a decent backdoor, and then potentially contributing back, right? Like what is the process of contributing back and those kinds of things? Because as we evolve, I'm trying to get a sense of the gap, right? Like our use cases, I think, are pretty simple out of the gate. Just at a glance, I think that SDK will cover them. It's good to know that Spotify is using that in production. But again, it's a big decision for us. We've kind of had a start and a stop in this area. I kind of don't want to backpedal. Once we kind of dip our toe in here, I kind of want to jump in with both feet, right? So that's really my biggest concern at the moment.
And I completely get it. Like that's absolutely fair. What I would say is the entire API surface, actually all of Flyte is written in Go. So it's a third language really. And the API interactions all happen through a gRPC REST interface. We actually would be interested in helping you build. So we are using Buff now. So Buff just generates the Java stubs for, these are just client interactions, right? Like if you're in invoke a workflow, get out, things like that. So, and we would be interested in actually integrating OAuth2 into that. That might be something that as a community, we would love to work with you together on.
Sure.
And actually, once you have that, getting that into Java, Scala, FlyteKit is probably somebody who's much better at Java, Scala than most of the folks in the community. Right? That's I don't think the path is going to be that far, but I understand your risk, and you should definitely measure that before you.
Yeah. Okay. No, I appreciate the feedback.
Thank you.
Awesome. Thank you, Andy. Thank you all. Right. Next up, finally, Byron Hsu and Troy Chiu introducing the flyteInteractive plugins. Welcome, guys.
Let me share my screen.
Ooh.
Yeah. So yeah, we're a bit over time, so I'll try to keep it short. Yep. Okay. So this is the demo for flyteInteractive plugin. And the main goal here is to allow develop ML model interactively on Flyte, because as you may know, on a general orchestrator platform, usually people just write their code locally and test locally and then submit to remote. But oftentimes you run into issue because of the environment difference from remote and local. And we'll dive into more detail later. So this is me and this is Troy, and we will share the slide later. And if you are interested in us, you can find us on the link here. So today's agenda is firstly, we'll talk about the pain point of the current ML model development on Flyte. And then we'll talk about how we innovate and approach to develop ML model interactively with our new plugin. And the third, Troy will have a demo for all our features. So let's look at the current model development cycle. So usually people will do local code change, and they will try to run some unit test on their local side. And then they do register and execute the workflow. So, okay, so what's the problem here? The first one is that in each iteration, you need to take the full cycle to reflect a change. And usually, if you considering the scheduling time and probably the Docker image pulling time, it will be at least like 3 or 4 minutes. And the second problem is that the unit tests on local are not representative, because the first reason is that on local you don't have you usually don't have GPU access, and on remote we usually just run like distributed training on AGPUs. So it's quite obvious the unit test is not quite useful here. And the second reason is data access. So in a lot of like cloud or on-premise setup, the local side doesn't have access to data, to data storage. So if you want to train a model on a real data set, you need to be on remote and have the connection. And then after unit test, you have to register. But every time you have to register again because you change the code. So it might be time consuming if you want to use like fast execute in Flyte, especially for your large code base. If your code base is large, it'll take time. And due to the previous reason that unit test is not representative, so the execution is usually likely to fail. Okay, so here comes the flyteInteractive plugin. So here's the previous workflow of how we develop the model. So our new approach is that we don't have to do a local code change unit test and register again and again. We can do all the tests on a production environment. And after we're done with the experiment, we can just submit and execute the task. So in very few words, flyteInteractive enables engineers to interactively develop models in remote using VS Code browser. So it's worth noting that the VS Code browser here is the open source project called Code Server, which is basically a browser version of VS Code, which can run seamlessly on the browser. So how to use flyteInteractive is super easy. You just have to make one line change to the code. So as you can see here, this is a normal Flyte workflow. So if we add VS Code decorator on a task, it will turn the task to an interactive dev pod. And then it will have a VS Code server running on the pod, and you can easily connect to it. And Troy will demo it later. Okay, so for comparison, the previous setting and the interactive dev, the primary difference are, the first one is that we have GPU in interactive dev testing, and then we also have data access, CUDA, and we have some use cases internally that we can run multi-nodes testing on Ray or Torch. And this is quite convenient because usually the distributed training bug is hard to find by like submit every time. It will be very useful if you have an interactive environment and allows you to debug. And then interactive dev also instantly reflect the change because you can just make a slight change in the code and then just run the program again and you'll see the reflection. And also it has pretty high success rate compared to the previous setting because you're in a real environment. Okay, I'll hand it off to Troy.
Okay, let me share my screen. Okay, can you see my screen?
Yeah.
Oh yeah, so I'm Troy, and I'm going to demo flyteInteractive. So imagine like we are developing a machine learning model training workflow. So you might have a like training workflow, and you have two tasks: get data, train a model, and calculate loss. And in real world, the get data might be like get the data from your data storage, like Byron mentioned, you probably cannot access it in the local environment, and in the train model task, the model might be super large that you cannot debug it in the local environment. So the original workflow might look like this. And right now, if you want to, for example, debug the model, and you write the train model process, and you run it in the because you cannot debug it in the local environment, as we just mentioned, so you will run it in the Flyte cluster. And to save more time, and I ran it ahead, so as you can see, we ran into an error, and it says the model size is not. So the model there is a bug in the model shape. So right now, if you without flyteInteractive, you have to debug it locally and register again and run it in the cluster again, and it takes a lot of time. So right now, the only thing that we have to do is add a VS Code decorator. It's a one-line change. So this decorator will launch a browser-based VS Code application in the task pod and expose the port. And once you connect to the port, you can develop you can debug the task in the pod environment. So you got everything you need. You got the data, and you probably need GPU, and so you got everything the same as production. So I also ran it ahead. So as you can see, these task doesn't fail, and it's still running, and you can see we open the code server, we launch a code server and expose the port, and because the port is exposed in the cluster, and I have to, so the thing that I have to do is I have to pull forward my local port to the cluster port. So let me do it. So I pull forward my local 8080 port to the cluster 8080 port. So right now, if I access my local host 8080, then I can access the browser-based VS Code, and here is all the things in the pod. So I can see the same Python script which is my training script. I can see the same thing, and I can even run my training script in the cluster, super easy. So yeah, you can do everything here. You can run the workflow here, the training workflow, and you got a data access, you got a GPU, you got all the environment. Okay, so besides the VS Code decorator, besides this browser-based VS Code, we also provide more features that you can help you easily debug your task. So the first one is interactive debugging. The VS Code decorator will automatically generate a Python script which allows you to feed the output of the last task as the input of your current task. So you can easily debug your task without like generating dummy data or something like that. So in the browser, yeah, as you can see, we run it, and you can see the model shape is wrong. So let me debug it here. I change the model size, and we also provide, as you can see, we auto generate this Python script. And one thing more convenient is that we also provide a launch.json. So the only thing that you have to do is click this button, start button, and the script will use the output of the last task to run your current task, and with your updated code. So I fixed the model shape and run the script, and so right now it's running with the output of the last task. Yeah, it's in my local machine, so it might be a little bit slower. Let's see. So one thing that I want to oh yeah, so you can see it run your task with your updated code, and also automatically get the output of the last task to run your current task. Okay, so it's the interactive debugging. And by the way, if you find it's slow to if you find it's slow to use these browser-based VS Code, you probably have to get more resource for this task, because if you don't have sufficient memory, then the VS Code might be pretty slow. Okay, so after you're done with debugging the task, you probably want to resume the whole workflow to see if the task actually works, because the task probably runs correct with the input, but the output might not be correct, and the whole workflow will not run correctly. So you probably want to resume the whole workflow and see whether it runs correct. So we also automatically generate a script, so that the only thing that you have to do is change to another launch plan and play this button to resume the task. So right now we have done all the debug, and we want to resume the workflow. So we just simply click this button. So to avoid accidentally to avoid accident, we will make sure the user want to actually resume the task, because all the things will the pod will resume, and you probably will lose something that in this VS Code. And so we resume it, and we go back to the console. So we should see the task succeeded. Yeah, oh yeah, the task succeeded, and we get a new output. So as you can see, we can interactively debug in the VS Code, in the browser-based VS Code in the pod environment. So you got everything you need, and you can easily get the input of your current task, and you can easily resume all the tasks and see the result of your updated code. So it's super useful. And we also provide some advanced features. For example, the first one is we can run your task first, and if the task failed, we launch the VS Code server, and if the task succeed, we do nothing. So you can add the VS Code decorator with this flag on, and if there's no error, then nothing happens. So you can keep it there, like always keep it there. And we also provide pre-post execution. So you can provide like a function that before the VS Code server is launched, you have to run this, and after the VS Code server is shut down, you want to run this. For example, you might want to upload your updated code to somewhere, so then you can put it in the post execution. We also allow you to use like any VS Code extensions. So for example, as you can see, because it is shut down, as you can see, there's like syntax highlight, because we actually install the Python extensions for you, but actually you can install any extensions that you want, including like Jupyter Notebook extensions, Copilot, anything you want. Okay, then here is all the like a look of these Flyte Interactive plugins, and we provide anything. We provide the documentation, source code, and this demo code. So if you got any questions, you can ask me or Byron. Yeah.
Awesome, thank you. Yeah, there are a couple of questions. First one from Sami. I don't know if it's already answered, Sami, if the previous task, in terms of using the output of the previous task as the input to the current task, is that clear to you, or?
Yeah, I think I can answer.
Okay.
So yeah, I think to put it in a very simple way, let me share my screen. So to put it in a simple way, having a VS Code decorator will turn the task to a VS Code server. Okay, and we provide two modes. The first one is interactive debugging, which allows you to get the input from the previous task and then use that input to be debugged. Because, for example, if you have a training task, it will probably depend on the previous data generation task. So you want to get the input to try to debug your current training task. Yeah, and the other feature is that because if you have VS Code decorator on the task, it'll become a server, so it will just hangs there for a certain time. But say for now, if you want to continue the task, you probably want to terminate the server and then run your modified code. So we also provide another feature allows you to end the current VS Code server and continue the task. Yeah.
Awesome. Thank you, Byron.
And-
Next question comes from the, sorry. Yeah. So,
Oh yeah, I saw your question. Yeah, we'll have a blog post from LinkedIn engineering blog coming hopefully in like 2 weeks or 3 weeks. We're at the final stage.
awesome. And yeah, my other question was, I see that there's a port forward operation.
Yeah.
And I know that adding ingress to it's probably not part of the scope here because it can quickly become a rabbit hole. But I don't know, probably any plans on actually removing the port forward operation and actually.
Yeah, good question.
Ingress?
So I think for this, the difficulty is that there are so many ingress setup and it differs from case to case. So it's hard for us to have a general solution on the open source side.
The way we set it up at Union, and Union is this managed Flyte service where we don't run the entire Flyte cluster in one Kubernetes cluster. It's split. There's a control plane that runs hosted by Union, and then the data plane part, which has like Flyte Propeller and a couple of other services that run on the user, like in the user clouds, in VPC or on premise or whatever they are. And you get a single endpoint. So it's public ingress that goes to our control plane, and then we use secure tunnel to send traffic when needed to the data plane. So this for flyteInteractive, what we did is we added another route. There's a proxy that runs one of those extra services that run on the data plane. Is a proxy service, a reverse proxy, I guess, in a way, that takes a path and finds the right target for it. In this case, that path is served by an individual pod. Some other services like Spark History Server is served by a single service that serves the history server for all Spark jobs. But in this case, the URL, the path is unique per pod, right? So the routing is set up so that you get this path that tells Union data plane that the user is trying to send traffic to this particular pod. So it finds the pod it finds the IP address of the pod on the data plane and send HTTP traffic to it, route the response back to the user, right? So it goes from the user browser to our control plane through the secure pod tunnel to the data plane proxy, and then from the proxy to the pod, and then all the way back, right? It does all of that for every single request. And then so from a user perspective, they are looking at the same URL. They launch an execution. They click the link in the browser that says VS Code. You click that, and it loads, VS Code in your browser. Go ahead.
No, I think I see.
Yeah. Since we're talking, one of the features somebody asked about is can we add that rerun button for any task that runs in a workflow in the UI. They were asking if we can have this button to relaunch in a debugger kind of thing, or debug this failed task. And this would be, I guess, relatively easy if they have already add VS Code on the task. But if they haven't, that will get tricky, right? You need to rebuild the image with a plugin, and maybe change the entry point somehow. I don't know if you thought about that or not.
That's an interesting idea. Yeah.
Yeah, one of the things Yi just mentioned, he just left, but he mentioned before he did, was to use the task resolver. Not sure if you are familiar with that in FlyteKit. So maybe VS Code runs as a task resolver instead of or I guess in addition to the
Oh, I
mode
see.
where it runs as a wrapper. So we can, when we rerun the task, we can add the task resolver as a parameter. So it will run VS Code first, and then you have the entry point, right?
Yeah.
Maybe something to think about. It'd be an interesting experience.
Thank you. Thank you.
Yeah, but it's awesome stuff. Yeah, appreciate you guys working on this.
Thank you. Any other question, comment? No? Okay, thank you, Byron, Troy. Great work. And with that, thank you all for staying this late. I learned a lot. I hope you enjoyed this meeting, and we'll see you in the next one. Have a good day. Bye.
Bye.